Next problem, determine the range of values of parameter A for which the linear time invariant system with impulse response Hn is equal to a raised to n, n greater than equal to 0, and n is even, and it is 0 otherwise. And it is stable. So we know that LTI system is, we write here, when summation k goes from minus infinity to infinity, h of k less than infinity. This is equation 1. Now next, given equation is h of n is equal to a raised to n for n greater than 0 and n even, and h of n is equal to 0 otherwise. That is, sequence h of n is present from n is equal to 0 to n is equal to infinity, and for even values of n only. So the limits of summation will change from n is equal to 0 to n is equal to infinity. So we will also replace h of k by h of n. So the equation 1 becomes summation k goes from minus infinity to plus infinity, h of k, it is equal to summation n goes from 0 to infinity where n is even, a raised to n. This is equation 2. Since n is even, to satisfy this condition, we will put n is equal to 2p. Now here value of p is 0, 1, 2, dot dot infinity. So n is always even for any value of p. So equation 2 becomes k is equal to minus infinity p is equal to 0 to infinity a raised to p summation p is equal to 0 to expanding the summation we get summation k is equal to minus infinity to h of k. So mod of a plus a plus dot dot dot. So now we substitute all these values, so it is equal to 1 plus dot dot, it is equation 3. Now this is geometric series, we write here this is geometric series. For geometric series we have summation n goes from 0 to infinity a raised to n 1 plus a square a cube plus dot dot, that is equal to 1 by 1 minus a if mod it is less than 1. Now equation 3 becomes, we can write equation 3 summation k goes from minus infinity to plus infinity mod of h of k, that is equal to 1 by 1 minus mod of a if a is less than 1. So we write here this condition, that is we write here this condition, which condition? If it is less than 1 indicates that the given series converges to 1 by 1 minus mod of a if and only if it is less than 1. Thus for system to be stable it is less than 1, this is the condition, otherwise system will be unstable. We write here otherwise system will be unstable. Next problem. Consider an accumulator which compute the running sum of all input up to present time and expressed as yn is equal to summation m goes from 0 to n x of m. Is it an invertible system? If yes, find inverse of this system. If no, then give reason. Okay, so what is given equation? We write first here given equation. So it is y of n summation m goes from 0 to n x of m. This is equation 1. Now expanding the summation. Expanding the summation, we get yn is equal to x of 0 plus x of 1 plus x of 2 plus dot dot x of n. Now replace n by n minus 1 in equation 1. So equation 1 become y of n minus 1 summation m goes from 0 to n minus 1 x of m. This is equation 2 and this is equation 3. Now expanding again this summation, expanding the summation. So we get y of n minus 1 is equal to x of 0 plus x of 1 plus dot dot x of n minus 1. This is equation 4. Now invert is, we write here invertible system. Is designed to generate original input. Invertible system is designed to generate original input. So if we subtract equation from equation 3, then we can get original input. So equation becomes yn is equal to y of n minus y of n minus 1. This is equation 5. Thus it is an invertible system, and this equation 5 indicates the equation of inverse system.